Problem 4 is about calculating power series. In part A, we asked to calculate a power series for 1 over 1 minus x squared at x equals 0. Of course, one could do it with a Taylor polynomial or a Taylor series, but this is much harder than what is necessary in this case. There is a hint given: use a geometric series. And typically, if we give a hint, this means that there is an easier solution than that is using that hint. And the assumption is that you do the problem using that hint. Okay, so what is the limit of the geometric series? What does the formula give us? The limit of the geometric series is that the sum over I goes from 0 to infinity. Careful, we start with the 0. A to the I is equal to 1 over 1 minus A. So here, if we now compare this limit with what we have here, we see that we simply have to pick that A is equal to x squared. So our series becomes the sum I goes from 0 to infinity. A was x squared, x squared to the I, which is the same as x to the I, 2I. And this already is the series, and this is all what was necessary in this problem. In part B, we are asked to find a power series for the inverse hyperbolic tangent. There is a note which tells us about the derivative. The derivative is exactly the function for which we calculated power series in part A. Furthermore, this is the part B of a problem, so very likely the best way for solving it is to use part A here. De facto, if you take the book and you look on page 801 in chapter 11.7, you see the example 5, which is for the inverse tangent. This is almost the same example, basically just a plus and a minus have been exchanged. So we can do exactly the same what was done there. Let's start by remembering from the previous part what was the series for 1 over 1 minus x squared. This was the sum. I goes from 0 to infinity over x to the 2I. Now we use term-by-term integration. Then we know on the left-hand side we get the inverse hyperbolic tangent plus some constant. So if we integrate, on the left-hand side we get the inverse hyperbolic tangent of x plus a constant. What is the constant? It's the inverse hyperbolic tangent of 0. And on the right-hand side we integrate this series, and we integrate it term by term. What do we get? We get the sum I goes from 0 to infinity integral over x to the 2I dx. And that's the same as the sum I goes from 0 to infinity over 1 over 2I plus 1 x to the 2I plus 1. Furthermore, what is the inverse hyperbolic tangent of 0? We claim this is 0 because the hyperbolic tangent of 0 is 0, and that's because the hyperbolic sine of 0 is 0. So the inverse hyperbolic tangent of 0 is 0, so we don't need to add anything. What we have here is a series. So our series is, if we want to write it out, that the inverse hyperbolic tangent of x is equal to x plus x cubed over 3 plus x to the 5 over 5 plus x to the 7 over 7 and so forth. If you just had given this summation formula, this would have been perfectly fine. If you write it out, that's fine as well.